Download this code from codegive.com, link in the description below. Achieving 100% test coverage is often viewed as a goal in software development. However, it can lead to several pitfalls, including false confidence in the quality of the code, wasted development resources, and tests that do not provide real value. This tutorial will explore why 100% test coverage can be misleading and present a code example to illustrate these points. Understanding test coverage. Test coverage is a measure of how much of your code is executed while running your tests. It can be expressed as a percentage, with 100% indicating that every line of code has been executed at least once during tests. Why 100% test coverage can be misleading. 1. False sense of security. Achieving 100% coverage can give developers a false sense of security, leading them to believe that their code is thoroughly tested and free of bugs. However, coverage does not guarantee that the tests are meaningful or that edge cases are considered. 2. Low-quality tests. To achieve 100% coverage, developers may write trivial tests that do not actually assert meaningful behavior or outcomes. Such tests can clutter the test suite and become a maintenance burden. 3. Ignoring business logic. Having tests that only cover the code paths without validating the business logic can result in tests that pass but do not reflect the actual requirements of the application. 4. Neglecting non-code considerations. Code coverage does not account for non-code aspects such as performance, security, and usability. Focusing solely on coverage can lead to overlooking these critical areas. 5. Time and resources wasted. Striving for 100% coverage may lead to diminishing returns, where the effort to write tests for trivial or rarely executed code paths outweighs the benefits. Code example. Let's consider a simple Python function and its corresponding test cases to illustrate the pitfalls of aiming for 100% coverage. Production code. Python. Def divide, a, b. If b equals 0. Raise value error, cannot divide by 0. Return a/b. Test code. Python. Import unitest. Class test divide function, unitest.test case. Def test _divide _positive numbers, self. Self.assert equal, divide, 10, 2, 5. Def test _divide negative numbers, self. Self.assert equal, divide, -10, -2, 5. Def test _divide 0 numerator, self. Self.assert equal, divide, 0, 1, 0. Def test _divide by 0, self. With self.assert raises, value error. Divide, 10, 0. Adding unnecessary tests just to achieve 100% coverage. Def test _divide 1, self. Self.assert equal, divide, 1, 1, 1. Def test _divide 2, self. Self.assert equal, divide, 2, 1, 2. If __name _equals _main __. Unitest.main. Analyzing the test cases. Meaningful tests. The first 4 tests are meaningful and cover the main functional requirements of the divide function. They test both valid inputs and edge cases, like division by 0. Trivial tests. The last 2 tests, test _divide 1 and test _divide 2, are added primarily to increase coverage. They do not add significant value, as they are straightforward cases that do not explore edge conditions or complex scenarios. Conclusion. While achieving high test coverage is desirable, Aiming for 100% coverage can lead to writing unnecessary tests that do not contribute to the quality of the software. Instead, focus on writing meaningful tests that cover critical code paths, edge cases, and business logic. A more balanced approach, such as striving for 70 to 80% coverage while ensuring test quality, can yield better results in maintaining a reliable code base. Best practices. 1. Prioritize critical paths. Focus on testing the most critical parts of your application first. 2. Write meaningful tests. Ensure that your tests verify the expected behavior and business logic. 3. Review and refactor tests. Regularly review and refactor your test suite to remove redundant or trivial tests. 4. Use coverage as a guide. Use coverage metrics as a guide, not a goal. Aim for quality over quantity. By adopting these practices, you can achieve a robust testing strategy that balances coverage and maintainability, ultimately leading to higher software quality.